Hello, this is Professor Kuehn and welcome back to Introduction to Astronomy. We've been studying the work of Martin Waldseemueller, a 16th century German map maker who had a strong interest in astronomy. We're looking at his work called Introduction to Cosmography. What, by the way, is cosmography? It comes from two words meaning, well, cosmos on the one hand, which is the entire universe considered as a well-ordered whole. That's what a cosmos means. And graphe, which means basically to write. So it's writings or drawings about the ordering of the entire universe. And he's going to be using his understanding of astronomy to inform his map making. We are on Chapter 2 of his Introduction to Cosmography, and this is on page 104 in A Student's Guide to the Great Physics Texts. In Chapter 2, he's talking about some of the geometrical terms that have to do with spherical geometry. He talks about the sphere, the axis, the poles, and so on. So in the previous chapter, he was reminding us about, you might say, plane geometry, angles, lines, circles, circumference, things like that. Now he's going to generalize to spherical geometry. He says that his work is really based on the work of Theodosius. Theodosius was a 2nd century BC Greek astronomer and mathematician. So if you look at page 105 in A Student's Guide, you'll see that he's talking about these various spheres. He says that there are, according to then modern writers, 10 celestial spheres, and that the 8th sphere is a sphere on which the stars are fixed. So just to remind you the setup here before we continue, we've got the Earth at the center of this celestial sphere. So here's the Earth, and then going around the Earth is the Moon. That would be the 1st sphere, so I'll go ahead and number that 1. The 2nd sphere, you would have Mercury going around the Earth. This is a bit of an oversimplified diagram, but this gives you the idea of what he's talking about. The 3rd sphere, then, would be the sphere on which Venus is traveling. The 4th one would be the sphere of the Sun. The 5th would be the sphere of Mars. I'm using these traditional symbols, by the way, for the various planets. That would be the 5th sphere. The 6th would be the sphere of Jupiter, and the 7th would be the sphere of Saturn. And then, of course, the 8th sphere would be the sphere of fixed stars. So that's what he's talking about, the material sphere or the celestial sphere of fixed stars. And then I guess there was debate what's after that. Some people argued that there was a 9th and a 10th sphere, depending on what your theological views were. Okay, and then he goes on to talk about the various aspects of spheres. He says if you have a sphere such as this celestial sphere, so if I draw this celestial sphere right here, remember this is the sphere on which these stars are located, he says, well, it's rotating about this axis right here, and these points on the tips right here about which it rotates, those are called vertices. The vertices of this celestial sphere, or hinges, he also mentions they're called. Up here, there is the Arctic pole, and down here is the Antarctic pole. And then he mentions that the term Boreas, well, I guess maybe I'll mention the Latin terminology. So Boreas in Latin means north. And so Borealis is having to do or of the north. I think he mentions this as well. So this is the boreal pole, and that's the Antarctic pole. And he mentions that we who live in the northern hemisphere, of course he was living and writing in Germany, he said we living in the northern hemisphere cannot see the Antarctic pole of the celestial sphere due to the curvature of the Earth. We live up here. So if the Earth is right here and Martin Waldseemueller is living up here, of course he cannot see the Antarctic pole because his horizon precludes him from being able to see it. And he says, though, that the southern stars can be seen by those who live on the antipodes of the Earth. That is, people living on the opposite sides of the Earth. That is, opposite footing of the Earth. You might think about it that way. So people who live down here on the bottom part of the Earth would be able to see the Antarctic pole of the celestial sphere. Let's look at chapter 3, where he talks about the circles of the heavens. He begins by saying that there are two kinds of circles, great circles and small circles. And he says that a great circle is one that divides the celestial sphere in equal halves, and small circles do not. So you might think about it this way. If you have a sphere like this, and you draw a circle on it like this, such that you have half of the sphere above that circle and half below, that would be an example of a great circle. On the other hand, if you draw a circle such that it does not divide the sphere in half, well, that would be a small circle. Now, of course, there are an infinite number of great circles and an infinite number of small circles, because we can draw a great circle like this, or like this, or like this. As long as it divides it in half, it would be called a great circle. And likewise, there are an infinite number of small circles. But he says the kinds of relevant circles on the celestial sphere can be divided into these two classes of circles. So now what he's going to do is enumerate the great circles and the small circles and state where they're located, at least where the significant ones are located. So what I'm going to do is I'm going to sketch out what he's talking about. So I'm going to first draw this celestial sphere like this. Okay, now just to orient you, this is the celestial sphere, and then Polaris is right up here. So that's Polaris. Okay, now let's start drawing. Actually, here's what I want to do. Let me enumerate the circles first, and then we'll say where they are. So the first circles he's going to talk about are the great circles on the celestial sphere. First of all, there is the equator of the celestial sphere. So some of this is going to be review from before, and some of this may be new to you. The second is the circle of the zodiac, and I guess we should be a little bit more clear that this is the ecliptic. The third circle is what he calls the equinoctial collier. Equinoctial collier. The fourth he calls the solstitial collier. Solstitial. Whoops, let me respell that. The solstitial collier. The fifth is the meridian. And the sixth is the horizon. These are the 6 relevant great circles. What about the small circles? Well, the relevant ones are 4. First is the Arctic Circle. The second is the Tropic of Cancer, or the Circle of Cancer, you might say. The third is the Tropic of Capricorn. And the fourth is the Antarctic Circle. Okay, so where do these lie on this celestial sphere? Well, the first one that we can talk about is the equator, right? So what is that? That is just a band, he says. It goes around the center of this celestial sphere, like this, and it divides the northern half of the celestial sphere from the southern half of the celestial sphere. So this would be right here. This would be the equator. Okay? And the second important one is the circle of the zodiac. So what I'm going to do, I'll tell you what, let me draw the Earth in the middle here, right here. And let's draw the circle of the zodiac. I'm going to make this in blue. And I'm going to draw this as a band. Like that. And as he mentions, this is divided into 12 equal parts. And I will go ahead and label them by the constellations that populate the various regions of the zodiac. So this point right here, where the zodiac intersects the equator, that is the first point of Aries. Right here, so there's Aries. And then the next one you have is Taurus. This is a bit of review for you. Then comes Gemini, the twins. Then comes Cancer, the crab. Then we have Leo, the lion. Then Virgo, the virgin. Then Libra, the scales, or the balance. Next we have Scorpio. Then we have Sagittarius, the archer. Next we have Capricorn. Then we have Aquarius. And finally Pisces, the fish. Okay. And so just to be clear about this, the zodiac itself technically is not a great circle. Rather, it is a line that goes around, and the midpoint of the zodiac, that is the great circle. And that line is called the ecliptic. So I suppose we could put a point right here and say there's a line that goes about in the middle of the zodiac. That is the great circle of the ecliptic. But he does mention that the zodiac stretches 6 degrees to the or above and 6 degrees below the ecliptic. So if you were to look at the width of this region of the zodiac, it is 12 degrees wide. That is 6 degrees above the ecliptic and 6 degrees below the ecliptic. And he mentions that it's called the ecliptic, because eclipses of the moon, or the sun for that matter, only happen when the moon and the sun are passing through the line of the ecliptic. So let me be a little bit more clear about this. The sun is always migrating along the line of the ecliptic midway, basically halfway through the zodiac, right? So let me be clear about this. The sun is always exactly on the line of the ecliptic in the middle of the zodiac, and it moves over the course of the year from Aries to Taurus to Gemini and so on all the way through the zodiac. But again, it stays on the line of the ecliptic. The moon and the planets, on the other hand, are not exactly always on the line of the ecliptic. They drift a little bit above the ecliptic line and a little bit below the ecliptic line. And they drift by a few degrees above and a few degrees below, but they stay within about 6 degrees of that ecliptic line. Now, it's called the ecliptic line because if the moon happens to be passing through the ecliptic line when the sun is, and they're exactly on the same, passing through the same sign of the zodiac at the moment they're both on the ecliptic line, then you would have a solar eclipse. And on the other hand, if the moon happens to be exactly on the opposite side of the zodiac at the moment it's passing the ecliptic line, then you would have a lunar eclipse. So eclipses only happen when the moon and the sun are both on the ecliptic line. Okay, and so that's what he mentions here in his chapter 3. So far we've talked about two of these great circles, the circle of the equator and the circle of the zodiac. Next, he talks about the equinoctial collier. What does the equinoctial collier do? Where is it located? Well, he says it passes through the 2 points of the vernal and the autumnal equinox, and also through the poles of the sphere. So if I were to draw a circle, a great circle that went up like this, through Polaris, and then down like this, and then through the other pole, also the south pole of the celestial sphere, the Antarctic pole, this would be the equinoctial collier. Because as the sun is moving through the zodiac, as it passes the equinoctial collier, that is when it is the equinox. Okay? What about the solstitial collier? The solstitial collier is, you guessed it, where it passes through the points of the solstices. That is the summer solstice up here, or the winter solstice, and also the poles of the sphere. So if I were to overlap a circle like this, that great circle would be the solstitial collier. So I'll draw that right here. The solstitial collier is the other great circle. Okay? Notice that these 4 great circles are fixed to the celestial sphere. That is, as the celestial sphere rotates around the Earth once per day, right? So remember, it's rotating around the Earth once per day. In this picture, those circles are fixed to that celestial sphere. The other 2 are fixed to the Earth itself, or fixed with respect to, WRT means with respect to the Earth. So the meridian circle, if you are standing at a particular location, let's suppose you are standing right here on the surface of the Earth, your zenith would be directly above your head. So I'm going to try to draw like a line like this that's touching the sphere. This would be your zenith right there. If you're kind of on the front face of the Earth and you're looking directly overhead, that would be your zenith. Now if we were to draw a circle, maybe I'll make this a green line right here. So this would be your zenith right there. And if I were to draw a circle that passes through your zenith and also through the poles of the celestial sphere, this is not going to be a very good drawing. Yeah. Okay, I'll just draw half of that circle like that. That would be a great circle. Oh, I'll draw the whole thing. Whatever. Okay, that right there would be your meridian circle. Now, why do I say it's fixed with respect to the Earth? Well, because as this celestial sphere rotates around, the Earth is sitting still, and so your meridian circle doesn't actually rotate. It just stays right there. And likewise, your horizon is another one that's fixed with respect to the Earth. I'm not going to try to draw this on here, but you might imagine if you were to draw a plane that's tangent to the Earth, where that plane, at the point where you're located, the circle at which it intersects this sphere would be your horizon circle. That would be a great circle. Technically, it's not exactly a great circle unless the Earth is infinitely small, but it's just about a great circle. It's a circle that divides the celestial sphere into the region above your horizon and below the horizon. Okay, so those are the 6 great circles that Waldseemueller makes mention of here. Now, let's talk about the small circles. This diagram is going to get a little bit messier when I do this, but let's go ahead and do it anyhow. So, first of all, let's do the easier one. Let's jump right away to number 2, the Tropic of Cancer. What is the Tropic of Cancer? Well, if I were to draw a circle that goes through the first point of Cancer, right here, what color do I want to make this? Let's make this kind of a light blue. So the Tropic of Cancer right there. And if I were to draw a circle that goes around like this, that is parallel to the equator, but instead of being down by the equator, it passes through the first point of Cancer. That is the Tropic of Cancer. And you can think about it as the trajectory through the sky that the sun moves on a particular day on the summer solstice. So because the sun is entering Cancer on the summer solstice, and as this big sphere rotates around, the sun is going to follow that trajectory around the Earth on the day of the summer solstice. What about the Tropic of Capricorn? Well, you guessed it. If you put a dot right here at the first point of the constellation Capricorn, and we were to draw a circle around the celestial sphere like this, that would be the Tropic of Capricorn. It is the trajectory that the sun follows on the day of the winter solstice. Okay? And now, let's do the last two. By the way, those are small circles because they do not divide the sphere in half. And now, let's do the two last circles. But first, I'm going to draw an axis right here. This is the axis, not of the celestial sphere, but the axis of the zodiac. So if you think about the way that the zodiac is tilted, if we were to draw a line that was at a 90-degree angle compared to that, that would be the axis of the zodiac. Let me just mention that here. That's the axis of the zodiac. Okay. And now if we were to take the point where the axis of the zodiac intersects the celestial sphere and draw a small circle around right there, that would be the Arctic Circle. And likewise, if we were to draw another circle down here where the axis of the zodiac meets the celestial sphere and draw another circle around right there, that would be the Antarctic Circle. So those are the four small circles that Waldseemueller mentions in this chapter, and we will stop there.